Hello again. It's Paul Beckwith. So I'll finish off my discussions on the Arctic Report Card 2020. So where I ended up in the last video I was talking about the Arctic sea ice in March and September. So this is the trend. Again, this is from the Arctic Report Card, which you can just Google, and I highly recommend you have a look at it yourself. So this is the 1978 to 2020 trend. This is the trend in March, the black line, the reduction. This is the trend in September, and you can see, huge declines, and the decline in September is the largest. Okay, yeah, basically, if you look at the slope here, it was flatter, and then it seemed to accelerate. It looked like it was going after 2012. If you just, in 2012, we thought, okay, this is heading straight down. But, since then, we haven't set a new record. In 2020, we almost repeated the record, and I explained a couple videos back as to why we think that is happening based on a paper from Jennifer Francis. The age of the sea ice, similar story. So this is the age of the sea ice. So 4+ years is the red. 0 to 1 first year ice is the dark blue. This was in 1985, mid-March 1985. So lots of multi-year ice. It wasn't just formed. This is melted out the previous summer and then reforms in the winter. It's first year ice, and then the thicker ice is in these regions here. But here's what we see in 2020. In mid-March in 2020, almost all of the fourth year ice is gone. Some 3 to 4 year ice, a bit of 2 to 3, some 1 to 2. But this is, the amount of first year ice is dominating. So here's a plot. This is first year ice. Okay. So the first year ice is this is multi-year ice down here. So there's more and more first year ice as we go forward. And the 4-year ice, we thought it was going to disappear over here, and it came back a little bit here. But the trends are ice is going. Now the sea ice thickness and volume. Okay, we've got cryosat satellites, IceSat-2, to measure the ice thickness, and that allows us to get the volume, and we can get anomalies. So this is the maximum ice. This is October to April. This is the winter season 2019 to 2020. Okay, October, November, December 2019, and then 2020. And you can see the minimum here, the maximum, the average. Okay, this is 2019 to 2020 is the black line. So we're far below average. This is the ice thickness. The ice thickness in the 1920 to 20 and the winter of 18 to 19. So thinner ice this year. Right, so although the ice extent is not setting new records each year, the volume is decreasing, the thickness is decreasing. This is the sea ice thickness histogram. So most commonly it's about 2 meters or so thick ice. Okay, this is the sea ice thickness for April 2020 here, and you can see there is, so the thick ice is here, nestled above the Canadian archipelago, and it gets thinner as you go out. This is the thickness anomaly. So in 2020, interestingly, we had some thick ice here, ice that was thicker than normal, and this was being transported out the Fram Strait out in this region. This was in April. Okay, so let's just continue on. Sea surface temperatures. So August mean sea surface temperatures in 2020, 1 to 3 C warmer than the long-term average over most of the Arctic Ocean. Okay, significant warming in regions that are ice-free, and significant warming in the Kara and Laptev Seas, up to 5 degrees C warmer than the mean August values because we had early seasonal ice loss in these regions. And it was extremely warm over Asia, over Eurasia, Europe, and then that carried right up into the Arctic. So let's have a look at the distributions. So this is the 2020 sea surface temperature in degrees Celsius. Okay, so the yellow warm area is extending up into the Arctic. This is the anomaly. So extremely warm in these regions here where we lost sea ice very quickly in the spring, and that way, for that reason, these regions had the entire summer to warm up. Okay, August 2020 versus August 2019, extremely warm up here in this region in 2019 and shifted slightly into these regions in 2020. Okay, this is the Kara trend, the mean sea surface temperature anomaly, increasing trend, and the Laptev. And look at the huge jump here, although it did it in some previous years. Okay, and then drop back down. So let's see, this is the mean sea ice extent in the Kara and in the Laptev. So, you know, of course, very, very low sea ice, very, very high warming of the sea around that sea ice. Ocean primary productivity. Okay, warmer oceans, no sea ice. Light can penetrate in, you get phytoplankton growth. Okay, so it's all connected. So we had higher values for 2020 of ocean primary productivity, the rate at which marine algae transform dissolved inorganic carbon into organic material from photosynthesis. Okay, all regions had a positive trend from the 2003 to 2020 period. Strongest trends in the Eurasian Arctic, the Barents Sea, and the Greenland Sea. During July and August 2020, a 600-kilometer long region in the Laptev Sea of the Eurasian Arctic, it showed much higher chlorophyll A concentrations, which shows you the amount of phytoplankton there. Basically twice as high in July and 6 times higher in August, comparing these months to the multi-year average of these months. So, you know, it's not just there's two sources. There's the single-celled algae that live in the sea ice, the ice algae, and then there's the water column phytoplankton. So, you know, there's algae that are growing in the sea ice, but light has to penetrate through the sea ice for them to grow. So as the ice gets thinner and thinner, more light can penetrate through, and we can get more of the algae living in sea ice. But then the sea ice goes completely, so we just have the phytoplankton in the water column. Okay, so the chlorophyll A can measure where things are, and here we go. So this is in May, June, July, and August, and the sea ice is the dark area. But you can see the green areas here where that's the measure of the chlorophyll A concentration, percent of the average. So up to 400% of the average. That's the average from 2003 to 2019. So you can see, you know, areas here in May, huge growth here, in June, in July, huge growth, and in August. So the sea ice goes, the light can penetrate into the ocean, it can stimulate the phytoplankton growth, and then the whales come. So this is the sea ice concentration anomalies in percent relative, again, to the 2003 to 2019 period. And you can see, you know, so red is negative, less and less sea ice, and you can see less and less sea ice in May, in June, July, and August, the huge anomalies, and look where the phytoplankton is growing in July and August in these regions. Okay, so less sea ice, more light penetration, huge amount of primary production. This is the trends over time from 2005 to 2020. Increases. This is the primary productivity as measured by grams of chlorophyll per square meter per year. And you can see the grams of carbon, rather, and you can see the trend. More and more phytoplankton growing in just about all regions of the Arctic, and the lines, the trends are the highest. This is the average of the 9 regions, the trends, and the trends are actually the highest in the regions that are losing the sea ice the quickest. So look at the Eurasian Arctic, 12.83, huge growth there. Next in the Barents Sea, 9.32, and then 4.47 Hudson's Bay, 4.35, 5.24 is the average. Okay, Bering Sea is the lowest, it appears. Okay, so huge phytoplankton growth, and therefore, also growth on land. Okay, it's not just growth. So that's growth of plants in the ocean. There's also a greening of the Arctic. So these are the regions here that are greening the most. There's a couple different metrics, NDVI, which is normalized difference vegetation index. Basically, it's the greenness of the plants measured by satellite, and you can see, in all these regions where the permafrost is becoming permamelt, you can get the greening and tundra, and the vegetation gets taller and taller. The forests move north. Okay, and this is the trend of these NDVIs in Eurasia, and also in the Arctic and in North America, northern parts of North America. Okay, so lots of greening of the Arctic, and because of the greening and the more phytoplankton, then the whales can go and feed. I'll talk about that in a minute. The glaciers and ice caps outside Greenland are also melting very quickly. These are regions where the glaciers are outside. The ones that aren't attached to the main Greenland ice sheet are shown here in red on the perimeter. Okay, and then the other glaciers around in the Arctic are shown, and you can see the cumulative mass change in meters of water equivalent for monitored glaciers. Alaska, huge drop here. Arctic Canada, slower. Iceland, significant drop, and so on. You can look at all of the glaciers are going, not just on Greenland, but all of the surrounding areas. Average summer temperatures increasing in the Arctic. The total mass balance, cumulative regional mass anomaly in the different regions all across the Arctic is. So if you add up all these losses of ice from the different regions outside Greenland, then you get this drop here. Okay, a significant drop. And the whales, okay, these whales are fascinating. They can live up to 200 years. They have unique anatomical and physiological attributes. Their sequenced genome holds promise for the advance of medical knowledge related to cell senescence, how cells die, bone biology, fat metabolism. Imagine if people lived for 200 years. In some cases it could be good. You'd have the Stephen Hawkins and the Albert Einsteins, but what about, can imagine Trump living for 200 years? No thanks. I think I'd rather have human lifespan being what it is. Thank you very much. So the whales, these are different regions where the whales are, and the whales are quite healthy populations. They're growing. They're almost at, in some regions here, they're almost at pre-whaling levels. Lots of them. They eat because the food supply is going way up. Okay, lots of stuff on the whales, the bowhead whales. These are fascinating creatures, and different feedbacks and stuff. Let's just keep going down. Coastal permafrost is eroding at huge rates. Okay, here's different regions of the Arctic, and here's pictures of the shoreline. So look at this. The water and the storm, with less sea ice, it's much wavier. And it's much warmer there, and the water's much warmer, and you're getting all kinds of runoff. There's a person here for scale. So this is regions A, B, C all around the Arctic, and you can see, these regions. You can see the white areas that are ice, right? Huge coastal erosion. We're losing islands and so on in the Arctic. And this is areas where there's very rapid erosion, is the dark red. And moderate erosion, red, and then slow erosion, yellow. So erosion around the entire Arctic region. Okay, thank you for listening.